Okay.
Hi guys, can you hear me?
Yes, Kennedy, we can hear you.
All right, perfect. So please just give me a bit of time. I'll share my screen so I'll get started with our discussion this evening. Just a bit of time. I'm with you guys.
Yes, we can.
Yes, Kennedy, we can hear you. Oh.
All right, guys. Can you see my screen?
Yes, we see your screen.
All right. That's perfect. Okay. Yeah. Sorry for the delay in terms of our session. So so guys, welcome to today's session. My name is Kennedy J. Uh, so I'll be taking us through this session. So this the session is going to have two aspects. The first aspect, we are going to go through a bit of what you guys have been going through in the lecture materials that you have access to on the platform, right? And we are going to look into simple linear regression, right? So we quickly go through the theory just to reiterate on what we have been going through in the course materials. Then after that, we go straight to the demo session. Do a bit of illustration on how regression works. So the first class is just a simple case, so it's not going to be that much of a big deal, but we're going to walk through all the steps needed to to perform a linear regression analysis, when you have data and all that. So it's a quick one. Linear regression. So basically, in the course content that we have for the week, this week is just about linear regression. Linear regression is basically an aspect of the supervised machine learning, right? Whereby in this case, we make prediction of a particular variable based on other variables, right? For instance, we look at how a variable determines the value of another, right? If you take this down to a kind of real life scenario, for example, house rent, yeah. So, a number of factors can affect or determine the price of rentage, right? So something like the number of bedrooms, the number of toilets, a number of features, kind of determining the value of a variable. So in regression, we kind of predict. We have an algorithm, train an algorithm to make prediction on a particular variable based on the values of other variables. So in this approach, the model is being fitted with data, right? So the model, we kind of study how kind of the relationship between the data and then use that relationship to perform a sort of prediction, to make prediction, right? So so that is just what this stuff what is all about. Yeah. So in regression analysis, we have two major variables. For a simple linear regression analysis, we have two variables. We have the variable that depends on the other variable, right? It actually follows a linear, a linear graph setting, right? So in a simple linear regression, the dependent variable, right? The value of the dependent variable is predicted, based on the values of the independent variable. So it actually, the model takes the form of a straight line equation. So those of us that are familiar with, algebra in mathematics, right? You should be familiar with this particular expression, y equals to ms plus c. So the simple linear regression takes the linear modern kind of format whereby we have the dependent variable y, and the value of this variable is determined by the independent variable x, right? So then we have, the slope and intercept. This is just describing a straight line equation. So what a regression model, linear regression model does is that when you give it a trend data, right, it tries to plot a sort of establish a line, sort of line of best fit, right? That will minimize the error, right? That's the difference between the actual and predicted value. So what it does, like sort of scatter plot. You have a scatter plot, and the model will try to get a line, in between the plot, such that that line will minimize the difference between the actual and predicted value. So it will now use that line to make predictions on a data set that it has not seen before. So this is just basically what a simple linear regression is all about, right? It takes the model of a straight line and then try to fit, the data in such a way that, it fits the data based on a straight line such that, the difference between the actual value and the predicted value is minimized, right? So now, for the fact that it is a simple case scenario, it means that a number of assumptions are actually made, right? Just to, have this work as a sound, simple linear regression. So the first assumption is linearity. So what it means that the model assumes that the relationship between those two variables is linear. So if the relationship between the two variables is not linear, the predictions made by the model will tend to be inaccurate. The prediction will not be accurate because the simple linear regression model is designed with the assumption that the relationship is a linear relationship. So that is an assumption. In reality, we don't have this, being true. But for a simple case of simple linear regression, this assumption must hold, right, for the prediction to be accurate in a way. Then another assumption of simple linear regression is independency. So what this stuff is trying to, represent is that in the case of a simple linear regression, right, the features are not dependent on each other. Like the features, they don't depend on other. They don't kind of influence each other, right? So let's take, for example, if you have the house rent, as I said earlier on, if you want to predict the house rent, the rentage of a number of houses, there are a number of factors that affect, that can affect the rentage, right? The size of the room, the number of rooms and all that. So what the simple linear regression is kind of, the assumption here is that all these features, they don't actually, like the number of rooms does not depend on, the size of the rooms and all that. So it's an assumption, right? So what it means that a simple linear regression case is just one to one kind of relationship, that is a single feature, affecting the dependent variable, just a single feature X, affecting, irrespective of all the features that may affect that particular dependent variable. So it's an assumption, right? So that is that. Then another assumption is almost scarcity anomaly. So, the assumption here is that there is a constant variance, right, of the dependent variable. And the assumption here is that the variance, there's a variation, right, of the dependent variable, the y variable is constant, across the independent variable x. So obviously is an assumption. So this assumption, is just to, allow the simple linear regression model to work effectively. Then normality is just like, normality is just Normality is just about the data being normally distributed. Like, you have a sort of U shape, and then what you have on the left side will be exactly the same as what you have on the right side. Okay. Okay. So that is that. So these are some of the assumptions on your lecture note. There are some other assumptions that I mentioned there, right? So this is just to brush through what you have in your lecture note, so that we spend more time on the coding aspect. But remember, as we are going through this, if you have any question, right, just type it on the chat. I cannot see any question at the moment, but after the discussion, I'll go through whatever question that you have on the chat. Right. So now, if you want to perform a linear regression analysis, right, a number of steps are going to be carried out. And these steps are very important because, the whole thing is not just about the modeling part, right? Because in the whole process, you need to, first of all, start with the data, because it is the data that, the model is going to learn from. So everything starts from the data. So the very first step in the linear regression analysis is data preparation. So it is very important we understand how to prepare data, because the quality of the data that we have is what will determine, how our model we perform. If the data is not well prepared and use the data to fit the model, the model will learn wrongly and obviously predict wrongly. And remember, these predictions in production can mean a lot of stuff. Okay, so we get into that over time. So these are some of the data preparation techniques. When you are working on the analysis, you have to check if the data you have, right, has missing values, or what we call null values, right? So once you have missing values, depending on the number, the proportion of the missing values that you have in the data set, right? In some options, you have to drop the null values, right? In some situations, right, you have to draw the null values if they don't contribute, if the proportion is not is very few, like 3% of the entire data set, right? So you can drop them off. But if the proportion is large enough, and dropping them off, we reduce the data you have drastically, right? You have to look for ways to impute, right, to replace the null values. So that is the various imputation technique. So in some situations, you can use the mean of the columns, right, to replace the null values. In some situations, you can use the mode, right, especially when when you're dealing with, let's say, data that is not numerical as such. You can use the mode. That's the one that is repeated, most in the column for the imputation. In some instances, you use advanced ML algorithms to predict, the values that will be used to replace the missing value. But whatever approach that you use, make sure you always check for missing values in your data set. Is a very good practice. Once you load the data set, you need to check them for missing values. And if you have missing values, then you handle them properly. Then another practice is encoding, categorical values, right? So in some instances, right, you have, let's say in the data set, you have, a non-numerical column. Now, but that column has a lot of categorical variable. Categorical, like you have category, let's say, let me use sex, for example, male, female. So you have male, female, male, female, like, feed up in your in the column, right? So if you want to perform a model fitting with that particular data the way it is, it's not going to work out very fine because these models work more with numerical values. So you have to encode. Encoding can be, using a particular numerical value for each category. Okay, there are some known techniques that can be used, like one-hot encoding, right? Or that we convert the variables to ones, to digit 1, 2, depending on what you have. Then can also use label encoding, or can use Python to write some, just do the encoding, right, using Python objects like dictionary and all the rest. Then after that, another preparation technique will be to split your data into a training and testing set, because you will not use the entire data set to train your model, because the truth is, if you use the entire data set to train the model, then the model will just learn from the data. But for you to know your model has actually understood the pattern that you kind of gave to it, you have to test. So that is why, and you cannot test with the same training data, because if you use the same data you used to train it to test it, the model will perform very well because it has already studied the pattern that you have in the training data. So that is why it is very important to split the data set into a training and testing, right? You can use proportion of 20 to 80, 20 for test, and then 80% for the training. But whatever you do, the training data should be bigger than the testing data. So that is that, right? So these are the data preparation technique. Additionally, apart from this three that we have here, right? Sometimes you can, perform what we call feature engineering, whereby you create new features. But let's just continue based on what we have. Then after preparing your data, then the next step is going to be model training, whereby you train the model. So train the model is just fitting the model with your data, your trained data, right? So the model is already there. So you have to create an instance of the model, and then you fit the model with your data. So the model will now learn with your trained data. And then after learning with your trained data, you have to evaluate the performance, using some metrics like mean squared error. So some of these metrics, you have them already as part of Python, right, package. So you just import them into your notebook and then and get the value. So we have some metrics that mean square error that measures the mean of the square of the difference between the actual and the predicted value. So the actual will not be the test data, while the predicted will be the data that is predicted by the model based on the same S value. Then we have R squared that explains the proportion of variance, right? So this is just what is after training the model. You just use this matrix just to know how your model performed, right? For example, this mean squared error, for the fact that it is squared, we expect the value not to be, negative. So the value will be bigger than 0, right? Now, but if the value is 0, it means that your model is perfect. It means that your model, there's no error. There's no difference between the predicted and the actual. So if the mean square error is 0, that's just what it means, right? So as the value increases, it means that you have a bit of deviation between the predicted and the actual value. So so that is that. Then yeah, so once you calculate all those metrics, right, you have to interpret them, right? Because at the end of the day, you are doing the modeling to solve problem. Okay, so you need to understand how to interpret the coefficient, intercept, and all this. So let's see, and then visualization. So after evaluation, right, you can use some packages and libraries in Python to kind of make some plots that will show the regression line, right? And while looking at how the data is distributed, around the line, to give a cleaner way of a kind of presenting your case as such. So because picture speaks obviously better than just words and sentences. So that is just what this is all about, right? Okay, so that is that. Now I'll take us to the notebook so that we see how this works. So let me know if you can still see my screen. I don't know I don't know how it appears. Maybe someone should just unmute his or herself and tell me, is it clear enough, or should I increase? Should I zoom it out?
Please, can you zoom in?
Can you hear me?
Can you hear me?
Screen is
I should zoom it, right?
Yeah.
I think it's very tiny. Okay, perfect. All right, it's even less than. I guess it's fine now, right? Okay, nice.
Yes.
Okay, fine. Nice. Okay, so basically, I just have to pre-populate this ahead of time so that we don't waste much time. So I'll explain everything, right? So that we understand how the workflow works, because that's the essence of this session, so that every one of us will understand the step, all those steps that are outlined, how to put the step into practice. So if you are working on a regression analysis project, obviously you get your data set, right? There are so many ways to get, on the internet, there is a particular, I don't know if you guys know about Kaggle. So you can go to Kaggle and download as much of, just explore and get data set. If you don't know about Kaggle before now, you can just go and search, and you see a number of data set. So so once you have the data set, now you want to perform. Obviously, it's not every data set that that is good for a regression analysis. Now we have a data set, and this data set is good for regression analysis. I have a data set that has a housing price data set, whereby I want to predict the price of of houses based on since we're looking at simple linear regression, so based on just one of the features. This is just a demo case. In real sense, we are not going to be looking at relationship between just one. In our next session, we look at something that is a bit practical, because because of how we arrange the whole stuff. So in the process workflow, the very first thing you do is to import the necessary libraries. Now, let me just advise you, tell you guys this. So when you're working on a project like this, to make your work to be a bit cleaner, right? All your Python libraries should be at the top. And let me tell you, it doesn't mean that all these libraries, when I wrote this stuff, I imported all of them right from the beginning. Some of them is only when I need them, I will not have to scroll up and import them. I get in the idea. So the idea is that it doesn't mean that you are going to, first of all, prepare everything, and then you now start working. Right? Like, as I'm working on this now, if there's need for me to import any new library, instead of me importing it within the notebook, I'll just scroll up and add it as the next line, right? Yeah, so the essence of this is to have your work to be a bit cleaner, because I used to see notebook whereby everywhere you see import from this, import from that in the entire notebook. And that makes the work not to be organized as such. So now we are importing NumPy. I don't even know if we're going to use that, but let's see. If you're not going to use it, I will clean it off. So we're importing NumPy for the arrays, and then pandas compulsory because we're manipulating data frames, and matplotlib. So I added an alias. So this guy is not compulsory, but the reason why I added as PLT so that I don't have to start typing matplotlib.pyplot anytime I want to use this guy, right? So if you add as and then put whatever you want to put here, it will still work so that you understand what this is all about. Okay, so Seaborn and matplotlib library are for the visualizations. You can't do what?
We can't see your screen anymore.
Seriously? Wow. So what happened? Was it just now, or it has been like that for a while?
I think you had a network glitch because you were cut out for about 2 seconds.
Oh, wow. Wow, sorry about that. How about now?
Yeah, it's showing now.
Okay, fine. Thanks for bringing up. Okay, so the Seaborn and the matplotlib for visualization, then the sklearn is where the modeling stuffs are. So first of all, instead of sklearn, we have model selection. So this is what we're going to use to randomly split the data set into train and test. And then we import linear regression model from sklearn.linear model. So sklearn is the library for the modeling. So everything related to the model, you see it here. Then the matrix. So we're importing the R2 score and the mean square error. So you don't have to start writing the formula, the square of difference between the predicted and actual value. Yeah, if you write the formula, you get the same answer. This one has already been, worked on, so you use it. So I'll go ahead and import all of them. Shouldn't take plenty time. Get you guys connecting. Right. So while that is happening, so while that is going on, all right. So imported. Now, the next thing is your data set. You have to load the data set. Now, the way you load your data set depends on, the type of data you have. So now I have a CSV file. So that is why I am using pd.read.csv. So you need to, after this session, you go and check for how to read Excel and other files, because it depends on the file that you have. So now I have this CSV file saved somewhere. I didn't want to, because I'm using a Google Colab, I didn't want to start importing the driver and all the rest. So I have to put it in my GitHub. So now this guy is reading this directly from the GitHub, right? So it works. If you're working with your Jupyter notebook in your local, you don't even have to, just download it in your local and save it in the right directory and then read it directly from there. So I'll go ahead and load the data set. So now I have the data set. Now, once you load the data set, what you do, the next thing you do is just to, you have to interact with the data set, know what the data set contains, whether it is exactly what you have in mind, right? So, because sometimes after loading this guy, if you open this, it will not be well formatted. So that is even what that will inform you whether you need to transform some columns, whether you need to rename some columns, whether all those kind of stuff. Yeah. So if I view the head, this will view I know you guys have done this before. So this will view the first 5. If I view the tail, it will give me the last 5. So if I do tail, it will give me the last 5. So because it started from index 0 to index 4999, so that means we have 50,000 entries. So let me take it back to head. Okay, fine. So if you look at this now, you see that this is a simple data set. So these are the features, the square feet, number of bedrooms, number of bathrooms. Then the neighborhood is categorical, right? So if you are going to use this for modeling, you have to encode it. Because as you can see, we have rural, suburban, urban, suburban. So, and this is exactly what you have scattered in this neighborhood column. So if you need to perform modeling with this, you have to encode it to maybe rural would be 0, then after everything, you can take it back to the form that you have. That is after you are done with the modeling. But for modeling, the model cannot do anything with this because models work with numbers, with digits. Okay. Then year built and then the price. So price is a target variable. So this is the variable that we are targeting. We want to be able to, predict the house rent if we are giving any data. But because we are looking at simple linear regression, so we just look at how a single feature affects the price, like how to predict this with this. Obviously, the result is not going to be accurate because we have just a single feature. We're going to get very low metric by the time we are done with that. But this is just for a risk. So after viewing your data, these are some other stuff you can do around your data just to see the shape of your data, number of features, that is number of columns. So there are 6 here, and then you have 50,000 rows. Then info will just give us some stuff about each of the columns. So there are 6 in number. So this will tell us the data type, yeah, so you can see all of them are numerical data type apart from the neighborhood that has object data type. So another interesting stuff here is the non-null count. So as you can see here, there are 50,000 entries and all of them are non-null. So which means that the data set we have has no missing value. Yeah, you get more of this when you download data from Kaggle. But the truth is, if you are working on real life project, let's say you happen to scrape a number of websites, to get this particular data set, obviously you have missing values, right? Unless in production setting, you have a data engineering team that we try to, make the data to be very clean and send the data to a storage, a point where the machine learning guys or data scientists, we put the data and perform, So this whole cleaning stuff, in most instances, will be done by data engineers and then the machine learning guys. But before you work, you have to confirm first that there is no missing value. Don't just because of the fact that data engineers have already cleaned and then you trust them, and without checking, you go and use data that is not good for your modeling. So there's no value. Another way to confirm if you have no value or not is by using the is no object. So data dot is null. So we can be able to do all this because of the fact that this data is a data frame. Let me show you guys. If I do, there's a type function. So I do type data. It will tell me that data is of type pandas.core. So it's a data frame, yeah, because we use our PD dot, we use PD dot read CSV to get that on board. So it's a data frame. So all the data frame object, that's what we're using. All this is null and all the rest. So we are checking if there is a null value in the data. And then this guy is to sum up all the null values if you have any. So obviously there's no null value. So the sum return 0 for each. So that means we don't have any null value for this. So now, because the fact that the data is clean, there is no null value, and so we can go straight to the prediction part. Before you fit your model, right? You have to, like I said, you have to get your X and Y. You have to get your target variable and then the features. So in this case, we're using a single feature because it is a simple regression analysis where we are considering how a single feature affects, the target variable. So in this case, or in this demo, and we are trying to predict the house rent price using the number of bedrooms. So if you look at this, so what I'm just doing is I'm trying to get the prices and if you look at this, I'm also trying to get a number of bedrooms. But if you watch this, you notice that I use double square brackets in this case. Let me show you. There's a reason for that, because the model expects the X variable to be in 2 dimensions, and the Y to be in just 1 dimension as such. So let me show you. If I try to, let me just do this way. If I try to read Y, so it's just, that's what the model expects it to be this way. So it will bring out all the prices. If I try to read X, you see how it's going to come up. So you have it as this with this. So 2D. If you try to get the X exactly how you have, like you put a single bracket here, the model will complain. I will not mind showing you guys that later on, but let's just continue. Okay, so now that you have your X and we have our X and Y, so the next thing is to split the data into a training and test set. So to split the data into training and test sets, you use this function, this object that we imported up there, the trend test split. So this particular function, it actually returns a tuple, right? So that is why we are setting it. It returns a tuple with four outputs. So there are 4 outputs. When you run this function returns 4 outputs. So the first output is the S train. The next is the test data. The next is the Y train, and then the next is the Y test. So whatever you set here will automatically be the X, the training data for the independent variable. Then whatever you set here will automatically be the X for, that is the test, right, for the independent. Then you also have the same thing for the dependent. That is what you're trying to predict, your Y. So you have your S train, S test, you have your Y train, Y test. Then this function, let me view this. So this function, it takes these parameters, arrays, test size, train size, random state, shuffle, and all that. So it takes this, this X, that is an array, and this Y. Then the test size. So the test size is where you divide the relative proportion of the data. So if you use 0.3, this 0.3 here is, just for the system to use 30% for the test. So if you use here as 0.2, it's going to use 20% for test and 80% for train. Like I said, the train proportion should be larger than the test proportion. Then the random states, I know if you look at your lecture material, you'll be seeing 42 for there, but it mustn't be 42, it can be any number. So this random state is just like to a kind of, save this in a particular memory in the system, so that if you run this thing multiple times, because this split is actually done randomly. So if you run it multiple times, you not get different, right? You're not going to get different random values. So the same set of values, that's what you have. Now imagine that multiple people are working on this same data set. So if you use this random state, everybody will arrive at the same the same result. So the random state is just to make this guy to return the same set of values, right? Every time anytime you run this. If you don't do that, if you run this multiple times, it will reshuffle, it will give you different, to set this into different values, because this is going to be done randomly, the trend test split. Then once you split, now we have the data set. So we have the S train. So we have the S train. They are just 40,000 because I removed 10%. So 10%, 20% rather went for the other guy. So we have just 40,000 for S train. So if you it's randomly, as you can see. If you look at the what do you call it, the indices, you notice that it's no longer uniform because it picked the value randomly, but just the same number, right? Based on the proportion you defined up there. All right, fine. Then after we are done with the split, the test trend test split, next is to create an instance of the model. So this is the model algorithm, linear regression, that we imported up there. So this is how we create an instance of it. So we are creating an instance of this, and we are calling it model. You can call it anything, just a variable. Right? You can call it anything, but it's just we're using it as an instance, a name for this instance, right? So I'll import it. Now, once you have an instance of the model, you can now fit the model to the training data. So do model.fit. So what this guy does, it takes the S train and the Y train, right? And the model will now study the relationship between X and Y, in such a way that it can make prediction of Y when provided the value of X. Just like after plotting your graph, and then someone asks you to find the value of Y when S is this. So you go to the S as this and trace the value up to where it needs your line of base fit. And then from that line of base fit, you trace it to the Y axis and then read off the value. So the model will do something of that nature within the hood because it's linear regression. Okay, so I'll just do that. Now, this model is fitted with the training data for the project. So once you're done with that, you can now, let me take this guy out for now. So you can now make your prediction. So the prediction is just like, you're saying the model should predict, the corresponding Y values for the X. Now, the X we are using here, remember, not the S that used to train the model, because obviously if you use the S used to train the model already know the pattern between that relation between that X and Y. So for you to know whether your model is working fine, you have to test it across a different data set that it has not seen before, right? So that's what we're doing. So the model should predict the Y values based on the knowledge that it gained from this step. So you should predict the corresponding Y values for this. So when you run this, the model will make the prediction. So let's check what the Y pred is. Let me do something. Let's check what the X test is. So the S test. So you see, so now the S test, so what the model will now do, it will pick this number of bedroom 5, and then based on the knowledge acquired, it makes prediction of, so as you can see, for the same 5, it made, because if you look at this now, this is 5, 5. So since the knowledge acquired is based on of this, so it will try to predict the same thing for 5 and 5, right? So as you can see here, it predicted this for 5, predicted this for 5, and continue that way. And obviously, I know that this guy here is going to be 5 as well, because that is what the model, the knowledge the model acquired was based off this digit. So that is that. So now, now that we have the predicted value, so what next? We now try to compare the actual value with the predicted value. So the actual value is the actual value of Y happen to be the Y test, the one that we created up there during that split. So so we compare it against the predicted value. So for that same 5, there's an actual value for it. So the model this model evaluator will now perform some calculations, just some statistical calculations between the actual value of this and the one the model predicted. So the mean square error obviously is going to be the mean of the square of the error. The error here is just the difference between the predicted and the test. So since it's a square, even the negative difference will be positive because of the fact that the square is an even function and all that. So it's fine. So that is what will happen here. You don't need to start writing formula square or whatever. This has been done already. So and we imported it up there. So when you run this now, it will perform that same calculation based on the formula I just mentioned on the Y test against the predicted value. Then the R square score will also do the same thing, and make the get the validated value. So this is just to print out the values, the coefficients, and see how. Obviously, I don't expect this to be, awesome values as such, because of the fact that the prediction is based on just one variable. And remember, why we're using just one variable is because this is simple linear regression, and you can't do this in practice because using just a single variable to predict another, the prediction obviously will not, because you need to combine a number of things, right, to get a real prediction. So, but it's fine. Based on the context, we can work with this. So these are the metrics. So you can see how large the mean square error is, and that is crazily very big. So it is what it is. Then so slope and intercept, because it plotted the graph on the hood. So the graph had this slope and this intercept. Then the R square score is this. So the value is between 0 and 1. So this is what we have. Right. We're going to discuss more about the interpretation of this when we look at multiple linear regression. That will be our next session where we consider how multiple features affect, the same price of household and co. We're going to use the same data. So that is that. Then another thing you can do is to plot a regression, a regression plot, right? So I'm doing this based on the bedroom and price because that is what I'm working on at the moment. So so from the main data, I just pick only the bedroom and the price, and then so what I did here, or what we have here, is just to take a sample of the entire data because there are 50,000. If you plot this plot, if you plot this if you generate this plot for 50,000, it's going to look very funny. But we just want to see how the regression plot, looks like. That's just so we just took we take just 15 and fix the state again using random state of 2. Like I said, you can use any random state, it's fine. So so this guy just we take a sample of the entire data set, just 15, and then plot a regression plot. So this is that Seaborn that we have here. So regression plot, the S axis is bedroom, the y-axis is price. So bedroom has to correspond with this column. This guy has to correspond with this column. Then the data itself is the data sample that we have. If you use the entire data, I will do that and show you guys how to look like. Okay, let me do that right away. If you use the entire data for this, it's going to look something like this. All right, it's going to take a bit of time anyway, but let's see how it goes. Crazy. So this is what it's going to look like. So these are just the plot, the point, and that is crazy. You can't say much, like, based on how it's looking. But let's go back to just a sample of 15, just to have a feel of how the plot looks like. So something like this. So this is the regression plot with 15 data points. So it's just a sample, so it's not accurate, right? So this is a kind of graph that is plotted within the hood by the model, and then use this line of base fit, for the prediction that you saw there. So what the model will do is, like, if the number of bedroom is so and so, it will trace it to this guy and get the value. But it's going to use the one that has the complete training data sample that tested it. So that is that for that. So all these ones, yeah. So this is the same thing as what I have here, but just a different using a scatter plot or PLT, and just the same thing, but using different. It's going to look like that one that I deleted because it's fitted on. It's the same graph, but instead of using, though this one is cleaner because because we use just 15 samples, right? So it's the same graph. So it's either you use this or you use this. So whichever, you get exactly the same stuff. Right, so basically that is that for simple linear regression. So I'll stop at this point. Then I'll take your questions. Right. So let me see if there is any question. Okay, someone is asking why is X. Yeah, actually explained that the model expects 2D. So let me show you. That is Bruno. So watch this now. I'll go back to that point. So here, now let's say I remove this and I use just this. Because one thing with all this coding stuff is that if there's an issue, you get a prompt that will tell you actually, like, there's an issue here. So I'll use that new I'm using this now for the split and, so if I get the S train now, you see is in 1D, like that heading is no longer there, right? So now watch what will happen. Let me create a new instance, right, to override the existing. Now I'll try to fit this. So it's going to fail. Now, and that is the cool thing. Can you see? So value error. And what's the error? It expected 2D array, but got 1D array instead. Does that make sense? So if you use this for the X, it's going to be a 1D array and the model will complain because, yeah, so I think it's good that as I've seen this, but it also has a suggestion, right? You can use array.reshape. So, but sort of to save yourself the stress of doing this, you can just take care of that using that double stuff, right? So, Bruno, that is the reason for that. Mustafa said, asked, how do we know if we are to use linear regression for a particular data set? So it depends on, like I said, it depends on the problem you are trying to solve. For example, imagine that you have a data set like this, university. Can you guys still see my screen?
Yes, we can.
All right, nice. So
Yes,
imagine
we
you
can
have,
see your screen.
yeah, thank you. So imagine you have university employee salaries. So this particular data set, let's say, it used to predict university employee salary based on the number of years of experience they have and their location and all the rest. Yeah, as far as they're predicting a particular value based on a number of features in the data set, then it's regression, right? So now, heart disease, you want to confirm whether someone has heart disease or not. You can't use regression because this one you are trying to classify, whether a yes or a no, that kind of a thing. So you can't use regression for this. So use classification for this, and that is going to be settled in for data science guys in stage C. So that is the answer to that question. Right. Lastly, Lainka, how do you get that slope? Is that you don't have to. The slope is actually calculated. You don't have to start doing changing over changing x, right? Divide the x to get the slope. It's already it's already calculated in the hood by the model because inside the model hood is more of mathematics, calculations, graphing, matrices and all the rest. That is just what the model is just is a mathematician, just something of that nature. So once you feed it with data, it performs a lot of calculations and fittings, right? So yeah, you don't have to do that manually. Okay. So I guess that is that. There's no other question. So I guess we call it a day because we are out of
Sorry,
time.
how can we get the slides on the code, the notebook?
Oh, okay. Yeah, I think I saw that question somewhere, but I was scrolling. I didn't see it again. Okay. The slide and the slide. Oh, yeah, you get that from the team. Yeah, I'll share with you get that from the team, from the coordinator, right? Yeah, they'll share that with you. So that is that. Is that fine?
So the last one,
Yes,
sir.
thank you.
Yeah, I'll share that. Then I also share the data set. So you have to
Just
download the data set. Okay.
That's fine. Thank you.
All right. Okay, now so you guys should take care and have a nice day. Bye, everybody.
Goodbye, sir. Thank you, sir.
All right. Thank you. Bye.
Thank you, sir.
All right. Thank you. So Messi, you can.
No, you are the one ending it.
Yeah, I see it now. It's fine. All right, now take care, everybody.